Hey guys, how you doing? Ron Zanette here. Well, here's the Thunderstorm build. This is the Merlin SM8 Case Labs case, powered by a ASRock Z77 OC formula motherboard with an i7-3770k processor and a couple of GeForce GTX 680s by EVGA, the superclock versions, and SLI. And the system is being cooled, the processor is being cooled by a Fantex TC14PE, one of those massive tower coolers, along with a couple of 140 millimeter fans in there. And the rest of the case is being cooled by a suite of Bitphoenix Spectre Pro LED fans. They're the blue. And they are keeping the system nice and cool. This is all air, and on air I was able to overclock this system to a stable 4.7 gigahertz. So anyway, I want to show you all the benchmarks that I have for it, and again show you how the Aquaero is going to be used to run the system both in a quiet mode and a performance mode. So what I hope to do is run some thermal sensors to certain places in the case, and then when the system gets taxed running a stress test or a game, that it'll, depending on the temps in there, it'll trigger the fans to crank up so that it'll keep the system nice and cool. And so that's the next thing I want to do. So let's get inside and take a look at placing some thermal probes and configuring the Aquaero to be able to hopefully do that job. And now there's tons of more features for this Aquaero software, but you'll see that when I convert this system to a water-cooled setup. So for now, let's get inside and place some thermal probes, and then we'll move further on down the line to show you some benchmarks for the system as it's configured. And here's a shot that I don't often get to show. A couple of kick-ass systems side by side. That's the my Corsair 600T Ash system over there. Well, I've got 4 thermal sensors coming off of the Aquaero, and what I'm plan is to do is to put at least one in the one of the 680s, and then one either on the tower of the CPU somewhere or down by the base of the processor, is to try to get a good indicator of when the heat's cranking up on the CPU. Don't know how fast it radiates to the tower, so I'm going to try to get it as close as I can to the base, but it's so big I don't know if I'll be able to find a place to do that. And then I'm going to have at least one hanging inside the case to kind of give you the temp overall in a certain portion or portions of the case. So I've got 4 sensors that I plan to work with right now, and that's what I'm going to do. These are not that long, so it may ruin the aesthetic, but for this testing anyway, or for now, some of these may be dangling in a obvious spot, so but that'll change once I get it water cooled. Alright, so let's see if I can get this one here maybe run through the case somewhere, or maybe I have a longer thermal sensor. Let's take a look. I was able to use some of the Bitphoenix Spectre Pro have a LED extension, so you can run the LEDs, power connections coming from the fan to an LED controller, and basically that's what I've done up here for the all of the fans in here, but I have a couple of extra ones, so I'm going to connect up the thermal probe, the thermal sensor, to one of these guys. That'll give me quite a bit of extra length to be able to run it, so I can put it nice and neatly outside of the case. So I'm going to go ahead and do that for a couple of these long runs, especially the ones going into the graphics card. So let's do that. All right, I'm going to probably position, I don't know if you guys can see, I'm going to position this first probe inside over by where the blower is exiting a lot of the hot air out the back of the case. So that's my plan, to put this first probe in there. So let me turn the case around, and actually I'm going to take off the door. Alright, so what we have here now is 4 thermal sensors placed in the case. I have one in the exhaust area of the first GeForce GTX 680, and I put it in that one as opposed to the second one because first one usually runs about 2 to 3 degrees hotter than the second one. I could put another probe in the second one, but I'm just going to do one there to give me a gauge on the temps coming out of that 680. And then I have a second temp. I don't know if you can see it, it's right here, and I put it inside the bundle of the power to the 680s. So that's kind of going to be like the case temperature. So it's kind of sitting in the middle of the case and not hanging glaringly outside of the case. So that's to give me a temp of the case. And then the third one I have mounted is over by the VRMs. I stuck it in between the block that is part of the Formula motherboard. So we'll see what those temps are in there, and we'll see when we're running this thing, if it cranks up. We'll see if a temperature rises on it. And so I'm going to use those. So far I've got the GPU, the VRM area, the case temperature just to monitor temps in the case. And then finally a fourth one that I added was into the, it comes down in the front of the case just before the second fan in the front flex bay. So that is going to supposedly, my plan for that is to give me ambient. Without having a probe sticking all the way outside the case, I have it right out in front of the fan. So it's not getting the temperature affected by the air coming in, although it's probably going to be the same. But it's right outside the front, in the front flex bay. So I've got GPU, VRM, case, and ambient. So those are 4 temps for this setup right now. Is what we'll be showing in the Aquaero. Alright, so let's fire it up and take a look at the temps, and then work on configuring the controller a little bit. So I'm not going to get into a lot of detail in configuring the Aquaero because I'm only using some basic features of it. I'm only using the fan controlling portions of it. So I want to have a quiet to performance profile, which is based on the temps of the GTX 680s and the VRMs, or from pressing the system and the processor. You would think those temps will escalate, and then that, if using the software properly, should control the fans to get them going from a quiet mode to a higher performance mode. And we'll see how that does in cooling the case. We have a couple of temperature points. One would be case temp, and then the other one is the ambient temp. So we'll have a couple of reference points to see how well that does. So let's see how we can configure it and test it. Okay, I've got OCCT running, and just a quick run. The CPU is currently overclocked at 4.7, and what we have here on the temps, I've got the first GTX is running at 30, almost 31 degrees. The probe at the VRMs currently has it running right now where I have it inserted at 26.8, and you'll see the case temperature in the middle of the case there. Now I have the door off of the case, but where it's running right now, we're getting a 22.9 degree, 94 degrees C, and then ambient is 22.8. So that's the temp probe right here in the front of this case. You can't see the probe, but it's sticking right out in front of one of the fans there. So now you see the VRM starting to crank up a little bit, which that makes sense. the longer the test runs, I would imagine that that temp would start to climb up even more, and actually probably be good. Let's see what the real temp shows. Is the CPU. CPU is running at 70, 79, 74, 74. So I guess I don't have the VRMs. I would imagine that would be a lot hotter than 27 degrees, unless the block is doing a good job. Well, I'm gonna move the probe around in there and see if I get a different temp. All right. Well, now I found a point inside of the heat sink over by the VRMs that seems to be moving up in temp. Alright, now let's see what happens when let's run Unigen Heaven. I'll try to run it in a window so that we can see the graphics card temperature go up, and I'll also run Afterburner to see what the true GPU temps are. GPUs, one is at 32 now and 29. So I have Unigen ready to run in windowed mode so that we can see the temps down here on the graphics card. So it looks like the temp of the graphics card is right at what the temp is according to Afterburner. And let's run this guy. So we've got the GPUs up about 59, 60 degrees C, and the temps in the exhaust are 46. They're climbing up there. They're probably about 10 degrees behind the actual temps of the GPU, which is to be expected. It's just it's being cooled. And then you can see, let's see, the case temp. I don't have the doors on the case. I'll put those on there. 22 degrees. The ambient coming in is 22.8, and the VRMs, they're not being taxed right now at 27. So maybe we trigger the fans to crank up when the GPU temp gets to be about 40 degrees, 45 degrees. If the running at idle, they're at 29, 30. Maybe when they get up to 40, we crank in the temps, the fans. So let's just make a note. That's what I'm planning to do. They're 73 degrees. And yes, it's almost 60 degrees in the exhaust. All right, so let's configure the fans now. Right now they're all running at 100%. Let's configure them so that they're quiet, and then kick on to 100 once temps crank up there. Alright guys, so I think I have it figured out. Let me take you, this is the overview page for the Aquaero 5, and it's got a couple of different sets of readings. Here at the top we have the fan profile. So right now the front flex bay fans are running at 51%, and the drop-in mount top fans are also running at 51%, and then the rear case fan is running at 100%. Now you'll notice for the front flex bay fans and the drop-in mount top fans, you see the RPMs vary. They jump around a bit, and I'm sure that's because both of those inputs on the fan controller are multiple fans. The front flex bay fans, I have 3 tied to that one, and then the drop-in mounts, there's 4 fans tied to that. So the fact that they jump around on RPM readings, I'm sure has something to do with multiple fans on there. Some fan controls, if you have multiple fans on one fan controller channel, you don't get any RPM readings. And then the rear fan is at 100%. And so I'll explain to you why that they're at different percentages of power. But the center section here, this happens to be a display of the temperature reading for the GTX 680. I have a thermal sensor in the exhaust portion of the GTX 680 for that one. And here it's showing you, I think max recently is 34, and then 32.6 I believe is the current temp, and then 33 is the average. And then down here, these are the thermal sensors, and I have one connected to the exhaust of the GTX 680 number 1, as I just mentioned. So that's currently running at 32.6 degrees. The VRM, I have a probe in with the VRM block, the heatsink, and that's at 27 degrees C. The case, I have a temp right in the center of the case, a temp probe there, and that's at 24.2. And then I have a probe right in the front of the case, in front of one of the flex space fans, so that should be the ambient temperature of the room, air coming in. So what I'm going to do now is show you the fan profile that I have set up to control the fans on this case. So I'm going to controller, and what I have here is I have two settings. On number 1, that fan is on full, so that's the rear case fan, and it's currently set at 100%. So on the previous screen you saw the fan running at 100% all RPMs. I don't have any LED control items set up, but down here at the bottom you have the GTX 680 number 1 is the data source, so I'm getting temperature reading from that temperature probe, which is currently at 32.5. And I've set up a curve controller. So the Aquaero allows you to set up a curve, and it's very flexible. You can set up in different ways. I currently have it set up so that the fan's connected to this, and that this is now both the flex bay, the front fans, and also the drop-in mount. Both of those fans are connected to this curve controller. They'll be controlled by it. So you're able to set up a curve controller which takes the temperature reading off the GTX 680 in this case, and allows its temperature to control the speed of the fans connected to this curve controller. So I have the front fans in the flex bay. Those 3 are connected to it, and same with the 4 and the drop-in mount in the top of the case. They're currently running at a 51% because the temp on the 680 is low. But as the temperature increases, and you see that curve, as it starts climbing up to see 40 and 50, 60, you'll see the percentage that of voltage that will be applied to the fans goes up. Once it tops out at 60 degrees or more, those fans will be running at 100%. So what I'm going to do now is run Heaven Unigen so we can get those to spin up, and also put the microphone on the front of the case so that you can see how it affects it. So, and also, so I'll put I don't know if you'll be able to see the fan speed. You'll see the fans go up, but I'll just move the mic now. And I'm going to put it in the front of the case here. So right now you should be I have the microphone. I have the microphone connected to just clipped on the front of the case. So at least you'll hear those fans, and if that doesn't do it, I'll move it to the top. So I'm going to run Unigen now, and what should happen is you will hear the fans increase, and the speed will, as the temperature right there on that GTX goes up. So let's kick it off and see how this works. You can see now actually the fans kicking up. Can't hear it. Temp on the GTX is coming up to 60. the panels on the case and the fans running. Obviously, the point of that is to help keep the graphics card cooler. So we're just about to hit the 60-degree point, but the case is doing a good job in keeping things cool. Alright, there we go. We broke the 60 mark, and you notice both fan sets at the top are at 100%. So that's pretty cool. That's awesome. You see the graph there too, showing the temperature climb from starting up to where it is now. So this Aquaero does the job, man. That's pretty cool. Alright, so what I'm going to do now is stop Unigine Heaven and let's see it drop down and see if you can hear the fan. The system is pretty quiet as it is right now. Those fans are great, and they are pretty quiet to begin with. We have now it in full performance mode. The fans running high, while the graphics and the system is running high, and it's doing the job. You see the temp on the graphics card dropping, and that's again the temp and the sensor probe in the exhaust area of the graphics card. I've got it now set at 4.7, and I'm going to run it for another 30 minutes. I've run it for a couple of hours on and off now over the last week here at 4.7, so I know that it's stable, and I'm going to go ahead and run it so that you guys can see it. I'm going to put it on OCCT, and let's see, let's get the temps up, although OCCT also has temps. In the ambient, here is ambient temperature is 24.35 degrees C. So let's run this guy for another 30 minutes, and then we'll come back. We'll come back and show you the results so that we have it on record, and then it's going to be time to show you all of the benchmarks. So we finished running OCCT for another 30 minutes, ran without any problems at 4.7. The core voltage is 1.2, and the temps that you see, the max the temps got running it like this with the Fantex cooler is about 80 degrees across, average across all cores, 77, 83, 80, and 78. It ran just fine, and we have here the CPU, LinPack, finished no errors for 30 minutes here. And so now we see that the core is stable. We're going to run Cinebench, Heaven, Unigine, 3D Mark 11, 3D Mark Vantage, PC Mark 7, and Crystal Disk. And I'll show you the results of those benchmarks. Coming right up. Alright guys, now I'm trying to get this system to boot at 5.0 gigahertz. I have adjusted the CPU ratio up from 47 is because I had the system running stable at 4.7. Now I've got it up to 50. I've got the base clock at 100. The spread spectrum I disabled. Speed step is still enabled and turbo boost is enabled. I have the voltage, turbo voltage and PLL over voltage set to auto. There are some special features in here that you can tweak. This is the long duration power limit, that's in watts. I have that set at 300. There is a long duration period that you can maintain that power as 128 seconds. There's a short duration power limit, some primary plane current limit, and secondary plane current limit. I have those adjusted to what they were from the 4.7 gigahertz clock. Then there's a feature of GT overclocking support. I'm not sure what that is, so that's still disabled. For memory timings, I've left it all at auto. I have it that recognizes the XMP setting on this RAM at 1600, so I've not touched that. That is running still fine. Extreme voltage, there's a capability to adjust that. I have that disabled. Some switching frequency, there's an enthusiasm for current. You can set it at a couple of different levels. Right now I have it set at the mid-level, not the high. CPU voltage I had to adjust up. Now currently at 4.7, this thing runs great at 1.216. Now I tried to get this to boot at over 1.4 volts, but this i7-3770k does not like anything going over 1.4. It seems. I've adjusted it down, I'm tweaking it down, so right now I have it at 1.395. I have CPU load line calibration. This is pretty awesome. This is, I don't know if you can see, you can't see it on here, but there's 5 different levels on this setting, and basically this is pretty much saying that the load line should offer the least amount of variance, so it should be as close to 1.395 as set. And then all the other settings are set at auto. So let's see what happens and how far I'm able to get with these settings. So I'm going to go ahead and save these changes. We boot. Alright, let's see what we get here. The Aquasuite is coming up to run. Oh, that's all running good. Alright, let's see what CPU Z has to say. I've got Intel burn-in test, which I doubt it will pass at all. And actually, I know it won't pass, but I will... there it is, 4.99, 5.0. Can you see that? Sweet. Alright, I have Intel burn-in Agent God set to run at a standard stress level one time, just so you can see it. We'll see what it does. I can get online and I can search the web and I can do a lot of basic stuff, but I cannot really burn it in. You'll watch the temperatures go up here as soon as I start it, and I think it will crap out. So I just hit the start button, and the temps already are at over 100. So I'm going to stop it. But it began to run, it's just the temps go out of whack. So, but it's running at 5.0. Let's do it again. But look at those temps. Even with that cooler on there. So water cooling this will be much better. There we go. So you saw it. It came up at 5.0. Well, that's it, guys. I hope you like the build. It was just an air build, but it was still nice, pretty powerful, and speedy system. I think the ASRock Z77 Formula over OC motherboard is a good motherboard. It does allow you to overclock it pretty straightforward. There are some profiles that that are preset for you to try it, but in my opinion, the voltages that they're preset for, I guess they'll guarantee you if your chip will handle it a high overclock, but they're way too high, and especially for an i7-3770k processor, I think it's just way too high. So I didn't like the presets. I had to tinker it with myself, and plus that's a lot more challenging. But it was a great build. I learned a lot about the Aquaero. I think that's going to be awesome. I cannot wait to use that controller with all the pumps and fans and everything in this system once I go to a water-cooled build. And the one thing that I had put in this system, the AX1200i, I did not connect up the Corsair Link. I will do that in the following build here, the water-cooled build. So you will see that. But for now, I really hope that you like the build, and you stay tuned for the next series, the next build, which will be a water-cooled build. And I hope that you enjoy this thunderstorm. I did. So if you did, please favorite and like. And if you're so inclined, please subscribe. That's it from Ron Zanut. And thanks for watching. And finally, I want to thank again Case Labs for providing the Merlin SM8 case, and Performance PCs for providing the BitPhoenix Spectre Pro LED fans and the Essentials Pro Pack cables and Alchemy cables for this build.